Alright, let's take a look at postulate 4.2, the side angle side postulate. It states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Now the included angle, you see this side here and this side here, this is the included angle. Same with this triangle. Side and side and the included angle. So what's this look like? So if segment AB is congruent to segment DE and segment AC is congruent to segment DC and their included angles, angle A is congruent to angle D, then triangle ABC is congruent to triangle DEF. Problem 2 wants to know if we need any other information to be able to prove that triangle DEF is congruent to angle FGD by side angle side. And if we do need any other information, it wants us to explain which information we need. So the diagram shows that segment EF is congruent to segment GD. And by the reflexive property of congruence, that segment DF is congruent to itself, segment DF. In order to prove that triangle DEF is congruent to triangle FGD by side angle side, we must have congruent included angles. So we need to know that angle EFD is congruent to angle GDF. So let's look at some fun problems. This is problem number 3. And it just simply wants to know, would you use side, 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 or side, angle, side to prove the triangle's congruent? Well, since we have two pairs of corresponding sides, we have this side over here, and this side over here, they're congruent, and this side over here with a dual congruence markings, and this side over here with the same thing, those two sides are congruent. And we also have this included angle between the two congruent sides that are also congruent. So we would use side angle side because we have two pairs of corresponding sides and their included angles are congruent. So what about these two triangles? Again, we have this side here that's congruent to this side. We have this side that's congruent to this side. But let's look at these angles. Over here in this triangle, this is an included angle between the two congruent sides. But on this triangle, it's not included. It should be up here. So because this angle and this angle are not the included angle between two congruent sides, there's not enough information for us to prove that these two triangles are congruent. So what about this pair of triangles? Would we use side, 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 or side, angle, side to prove these triangles congruent? This one's pretty simple since we have one congruent marking here and one here, so these two sides are congruent. We have two congruent markings here and two here, so this side is congruent to this side. And we have three congruence markings here, so these two sides are congruent as well. So we could use side, side, side because we have three pairs of corresponding sides that are congruent. Finally, what about these two triangles? Would we use side, 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 or side, angle, side? Let's take a close look. We have a side here that's congruent to this side, single congruence markings, and then we have double congruent markings here, so this side is congruent to this side. We have three congruent markings on these two sides, so this side is congruent to that side. But we have the special angles here. These are vertical angles, so we have an included angle as well. So we could use side, 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 or side, angle, side because all three pairs of corresponding sides and a pair of included angles, the vertical angles, are congruent.